Welcome to Code Report. I'm your host, Connor Hoekstra. Let's take a look at the contest that happened last week.
Last week we had 5 contests. Throughout the week we had Week of Code 36, we had Code Forces round 461 on Wednesday, the Goldman Sachs Code Sprint started on Friday and went for 48 hours, and then on Saturday we finished the week with Topcoder SRM 729 at noon, and of course the weekly LeetCode contest, Contest 71. Taking a look at the top 10 leaderboards, we can see Yui's name all over the place. He came second in the Week of Code 36, first in the Div 1 Topcoder SRM, and only 8th in the LeetCode Contest 71 because he made a mistake on problem number 2. We can also see Petra coming in second place in the Div 1 on Topcoder SRM 729. The problems I'll be covering in this video today are problem 2 and 3 from LeetCode Contest 71, and then I'll be releasing videos later this week on the other 4 problems listed below. So let's take a look at our first problem. The first problem we'll be covering is problem 2 from LeetCode Contest 71 entitled Rabbits in Forest. The problem states, in a forest, each rabbit has some color. Some subset of rabbits, possibly all of them, tell you how many other rabbits have the same color as them. Those answers are placed in an array. Return the minimum number of rabbits that could be in the forest based on this array. And note that the maximum length of the array will be 1,000, and each of the answers will be between 0 and 999. So let's take a look at an example. In this example, we have 2 rabbits represented by the 0 saying that there are no other rabbits with the same color as them, and 3 rabbits that are saying there is one other rabbit that has the same color of them. So this looks like this visually. So we've got 3 rabbits claiming one other and 2 rabbits claiming 0. And we could color these rabbits so that what they're saying is true. So in order to do that, it's easy for the rabbits claiming no one else. All of them are going to have a different color. And for those that are claiming one other, we know that those are going to be pairs of 2. So we have 2 of them painted red and 1 of them painted blue. So note that if in order for what the blue rabbit is saying to be true, there has to be one other blue rabbit. So there's a missing blue rabbit from the picture. And so this is basically what informs our algorithm. We just need to keep track of how many rabbits are saying n other rabbits exist with the same color as me, and then do a little calculation to check to see how many rabbits are we potentially missing and return that. So the way we're going to do that is by taking a map and inserting what the rabbit is saying and keeping a count of that. So that's the group is what we're inserting, and the value will be how many rabbits are claiming that. And then all we do is we divide A by B and take the ceiling of that. So that will basically back out that we need to have 2 groups of rabbits in the claiming one other category. And then once we seal that division, we just multiply it by the number of rabbits in that group, which is going to be column D, and then we just sum this column. So the answer for this array will be 6. So let's take a look at our code. It's pretty simple. We've only got 5 lines. We start by declaring an unordered map. The key will be an integer and the value will be a double. The reason the value is a double is so that when we're doing our division, we're not doing integer division. We're going to have a remainder or a decimal. The second line, we're just inserting our keys and values into our map, and you can see we're doing a +1 here. That's so that when a rabbit says that there's one other rabbit, we're inserting a group size of 2. We then initialize our result that we're going to return, and then we do our calculation here. Result plus equals the ceiling function, and then we have our division of the number of rabbits claiming to be in group size, which is the first, and then applying the multiplication of the number of rabbits in that group back to this number. And here is a more STL version of this, so we can reduce the solution from 5 lines to 4 lines by using a lambda and the accumulate function. So here we're just creating a lambda that does our calculation that we want, and then using the accumulate function. And of course, this solution is going to be linear in runtime because we only have one loop, and our insertions and retrievals on our unordered map are constant. The second problem that we're going to be covering in today's video is problem 3 from LeetCode Contest 71 as well, entitled Reaching Points. The problem states a move consists of taking a point xy and transforming it to either x and x plus y or x plus y and y. Given a starting point sx and xy and a target point tx and ty, return true if and only if a sequence of moves exists to transform the point sx, sy to tx, ty. Otherwise, return false. And note that all 4 of the values you are given will be integers in the range 1 to 10 to the power of 9. So here's our example. Sx and sy start at 1, and tx and ty are 3 and 5 respectively. So those are the numbers we want to end up at. So we can represent this with 2 sets of parentheses as so. And if we follow the following steps, we can get from 1, 1 to 3, 5. So add the x to the y, which will give us 2 for y, then add the y to x, which will give us 3 for x, and then add the 3 to the 2, which is the x to the y, which will make the y 5. So at this point, we now have our sx equal to tx and our sy equal to ty. And so what you'll notice is that we can basically just reverse engineer this process by always subtracting the smaller of x and y from the larger of x and y. So starting with tx and ty. So if we start with 3 and 5, because 5 is larger, we should subtract 3 from it, and that'll bring us to 2. And then because now 3 is larger, we subtract the 2 from 3, and so on and so forth. And basically repeating this algorithm will give us our solution. So this example will return true. So let's take a look at our code. So here we start simply with a while loop. The condition inside the while loop is continue to do this loop while sx does not equal tx or while sy does not equal ty, because that's what we're trying to work towards. In our first line of our while loop, we have a condition if tx is less than sx or if ty is less than sy. We know we've gone too far, so we have to return false because we're going to be modifying tx and ty. And then simply, as we showed in our example, we only have to do one of 2 things. If tx is greater than ty, we have to do a minus equals on tx and vice versa. And note that this simply just isn't subtracting tx, because if we only subtract tx, it's going to exceed our time limit. So what we're doing here is basically backing out the maximum number of subtractions that we would end up doing. So for instance, if your x was initially 10 and your ty was 1, you would keep subtracting 1 from 10 until they were both equal to 1. So you can just get that number of subtractions by taking the difference and then dividing it by ty or tx for the corresponding examples. And note that we have this maximum because we always need to subtract at least 1. And this will give you your solution. So the runtime of this algorithm is definitely less than linear, and I would say it's roughly equal to log n, where n is equal to tx plus ty. Taking a look at the contests we have next week, we once again have a busy week. We have 3 contests from Code Forces, round 462, round 463, and Educational 38, all taking place from Wednesday to Friday. Then at the same time, we have Educational 38 on Friday morning. We also have a Hacker Rank contest, Rookie Rank 4, starting at 11. And of course, we are finishing the week with our weekly LeetCode contest on Saturday evening. Taking a look at the analytics, the top 10 viewing countries, so United States has pulled into first place ahead of Canada, India moving ahead of Germany into third place, and a couple dropped. Ireland and France and UK had the biggest skip, 3 spots from 8th to 5th. And our newcomers, Brazil in 7th, Lithuania in 8th, and Sweden in 10th. A shout out to those countries and all of the countries viewing around the world.
As always, if you enjoyed this video, hit that like button. Make sure to follow me on Twitter for reminders 30 minutes before contests start. You can find all of the code that I use in my videos on my GitHub page. All of the links are in the description down below. And finally, if you want to make sure you don't miss any of my upcoming videos, make sure to hit that subscribe button. Thanks for watching, and I'll see you in the next video.